this is the bank turn with friction. So we're setting up the same thing we did before. There's our angle theta. Okay, here's our card that's going either out or into the page, doesn't matter which. Sid, on your problem is the question, what is it asking for?
It's asking for what is the maximum speed that a car could go without skidding.
So we don't want it to slip. Now, yeah. So it's asking for the maximum speed. So let me ask you this, and it's going to take a little bit of conceptual or intuition. If you were going too fast and you started skidding, which way would you go on this hill? You can think about it on a flat plane. It is similar to a flat plane. If you're going around a turn and you're going too fast, do you go outward, do you slip such that your radius is bigger, or do you slip such that your radius is smaller if you're going too fast?
Your radius would get bigger and you...
Yes. So what's going to happen is it's going to slip up the hill if it's going too fast, which means we're going to have to figure out which way friction is going. So let's go ahead and draw the ones that we had before. Same as before, if this is mass M, I've got mg going down. I am making my coordinate axes like this again. It is xy like that, xy, right? Does that make sense? Yeah. The other force we have, we got the normal force again. That's the same. Okay, somebody is, hold on a second. I got somebody at the door. Can you guys hold on a minute?
Yep.
All right, they went away. Okay. Next up.
But you have two other students there.
Okay, cool. Let me are they not getting let in the room or something?
No, they're in the same room.
Are they in here? Okay.
Sydney Wilson and Kayla.
Okay, hold on a second. Let me figure out how to get back to this. Shoot. Okay. Let's see who's here. Hey, Sydney and Kayla. Hey, you guys, I'll be right with you. I'm helping Sid set up this problem, and then I can answer your guys' questions. Is that okay?
Okay.
We'll move them to another room and leave.
Okay. Or here's a great option. Dr. Lev is a PhD physicist who volunteers with us. I'm gonna just put you guys in a breakout room with him just for a second. He may just be able to answer your questions. Is it about the math one, or what is it about that you guys have?
It's just like a technical one for WebAssign.
Okay. What is
it? Certain parts of it won't let me submit my answer. So I want to know if I can email you those answers.
Okay, it's no worries. You don't even have to email. We just got to figure out the reason it's probably not is you may be on saved answers. If you on the bottom it'll say showing saved answers, show submit. It'll give you a choice: showing saved or showing submitted. You want to show the submitted ones because what it's doing is it won't ever submit anything saved. It's like, no, you want to save this. You don't want to submit yet, right? You got to go to it. You click on the bottom of the problem. It'll say either submit or show submitted answers. And I can help you on that if Dr. Lev can't.
Yeah, I'll just wait for you.
Okay, and then was that Sydney or Kayla? I can't see you guys on my screen.
That was Kayla, me.
Okay, Sydney, what was your question?
I just have like general classroom questions.
Okay, what is it?
Okay, so are we supposed to have a textbook or anything?
There is an optional textbook, but I rarely use it, so I'm not going to make you guys go to the school and get it.
Okay.
If you want a textbook, there's some great online textbooks. If you just Google OpenStax with an X, S-T-A-X, OpenStax Physics, you can get some excellent textbooks that are free.
Mm-hmm.
Any other easy questions I can answer?
And then about the written work for WebAssign, so you want us to just like write it down on paper, and if you ask for it ever, we just send
exactly.
You photos?
You just write it down on paper, and what I typically do is I'll just collect one shown work per unit. I'm not going to tell you which one it is, and it doesn't have to be super neat. I just want evidence that you are doing the work, and that's so it could be very messy, but you know, if you can number each problem just so I know which problem you're doing, typically I will just spot check a couple of numbers. And it's more about that. I want to give you credit for going through the process. Even if you can't get a problem right, I will help you with it. But I want to give folks credit for doing the work. That's really the important part. Does that make sense?
Okay. Yeah, that makes sense.
Awesome. If you need any help on any of this stuff, I can send you into a room with Dr. Lev until I'm done with this and then bring you back. Or you can just chill out here as you prefer.
Well, that's all I had. So I'm going to go now because
okay. Have a great weekend. Thanks for coming in.
Mm-hmm.
And Kayla, you're just going to chill here for the moment?
Yeah.
Okay. All right. This is something you got to look forward in AP Physics. Sid, are you still with us here?
Yeah, yep.
Okay, great. Anyway, we've got, where we left off here is we've got, these are two forces, but there's also a frictional force. Which way is that frictional force? I'm going to use different colors here. I'm going to use red for our normal force here, and I'll use a blue for the frictional force. Which way is the frictional force if it's going too fast?
I'm pretty sure it's down. It's like,
yeah, the friction. Down. And here's the weird part. This force right here, that is static friction, F sub S, because it hasn't slipped yet. Right. Even though the car is rolling, you get to use static friction. This is why ABS works, because you get more friction generally when you're not slipping. Mm. So, okay, there's FS. And what I'm going to do is I'm going to, just so it's not confusing, it kind of looks like a component of mg there. I don't want that to be confusing. So I'm going to take my eraser, and if I can get my eraser to work, and I'm going to make this, I'm going to make it a totally different color than mine. I will make this one red. I've got, I already got a red. I'll make it green. I've got the force of kinetic friction this way. I'm gonna make, yeah, I lost a couple forces there. I got to go back and fix those. F of static friction is right there. I got to redraw my force of gravity, which I unintentionally erased. Okay, there we go. Okay, there it is, like that. Now, again, with this bank turn problem, you do have to set up your coordinate axes like that. And what I'm going to do, because I know I have to do this, I am going to go ahead and draw in components even before I set up my X and Y columns. Let's see, do I have it all? Normal force, force of gravity, force of static friction. That is all there is right there. And I'm going to make this a little bit longer just so I can deal with that. And let me ask you this. I got to make some components here. Which forces do I actually have to break up into components?
Static friction and the normal force. That
is correct. So notice the mg is already set. So what I'm going to do is I'm going to do this normal force thing in the same colors, dot, 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 dot. What I've left out, you got to put in the arrows there, crucial. Okay, and I'm also going to just move, I always make this mistake. I'm just going to move my little label of N there to the outside. There's N here. That's the normal force. And I've got that one. Then as you mentioned, I also have to do the force of static friction. That's going to be this component. Whoops, wrong color. Need the light green. Okay, try that. This component and that component. There we go. Now I got to get these angles. And this is, again, this, I'm going to use the red and, I'll use, let's do some other ones. I'll use orange for this side. There's orange side of that angle. And then I'll use something else. Do we have another color I haven't used? How about the brown, which kind of looks like orange, unfortunately. Okay, so I've got orange and brown there. Let's look at the normal force first. Am I going to look for parallels or perpendiculars there?
Perpendiculars.
Yep. Do you have a perpendicular to brown?
Yeah.
What is it?
It's the vertical side.
Yeah, and this is, I should have named that, that is N sub Y. And then what's the perpendicular, this is orange. So that's the perpendicular to that. No, this one is perpendicular to, yeah, no, that's parallel. So let's see, what did I do wrong? NY, I'm looking for perpendicular to this. It's this one, right?
Yeah.
That one right there, orange. So that means my angle is right up here. Did I get that right for starters?
Yeah.
Okay. In the FS triangle, though, it's all different. Do I have a parallel or a, what am I going to be looking for in this F sub S triangle? Parallels or perpendiculars?
Perpendiculars.
Let's see. I've got a perpendicular to brown right here. Do I have a perpendicular to orange in that one?
No.
No. So for this one, the way I've drawn it, at least, there may be other ways to draw it where you will get perpendiculars. I got to use parallels. So again, let's see. I'm on the format. I need orange here. Orange, this is parallel to orange right there. You see how this one is parallel to brown right here?
Yeah.
So which angle's theta then?
It's the one in the top left corner. Yeah.
There we go. Now I can actually set up this crazy situation, okay? And again, this is the maximum force, so I'm actually going to call this FS max. And the reason I do that, the way this equation works, Fs, the force of static friction, is less than or equal to mu s times the normal force. Another way to write that is Fs maximum equals mu s times the normal force. You see how those two equations are equal? The maximum force you can get, if I pull on this computer, I can pull it with 1 Newton, nothing happens. I can pull it with 2 Newtons, I can pull it with 3 Newtons, and all of a sudden it starts to slip. That maximum force that you just have to exceed is Fs max. That's where some people prefer this formulation because you have an equal sign, because people get blown away by that less than or equal sign. It just means that this is the biggest force you can get. It's saying the same thing, right? So I'm actually looking for that force because I want to know the maximum speed, right? So that means I need the maximum force of friction to prevent me from slipping. Let's go ahead and do our X and Y table as always. I find this more than anything else. When a grader on the AP exam sees that you do an X and Y table, the relief is palpable because they go, oh, cool. This kid knows how to do physics. You would not believe how many kids don't do this, and they try to add X and Y numbers together, which never works. As soon as you do this, it's a signal to the grader, I know what I'm doing, follow my two-dimensional problem, and they're like, yeah, this kid knows it. And it's a really easy way to make sure you don't mix them up. In the X direction, again, all I ever write, I always write that to get a point. Fx, net force X equals max, net force Y equals may. Then what I want you to do is I want you to fill in this equation, and I'm going to help Kayla real quick. But go ahead and go ahead and put in the next step. I want to see if you get that right. Kayla, we're going to take a little break on this problem. What can I help you with?
I actually just figured it out as you were talking.
Okay. Was that the issue with the problem it wouldn't let you submit?
Yeah. I had to re-log in. It was something troubleshoot it. Okay,
cool. So you figured it out though?
Yeah.
Rock on. Keep up the great work. As I said in my text, you are in the exact right class. This is going to totally help you reach your goals.
Thank you.
Awesome. Have a great weekend.
You too. See you on Monday.
Later. Okay. Sid, do you have
Yeah.
What do you got here?
So I said n sub x plus.
Okay, great. And I should have labeled that n
sub x.
So n sub x, and that's a positive because it's going to the right. The way I've decided positive is x positive, y positive. Okay. What else in that direction?
And then I said plus static friction sub x.
Aha. So let's go ahead and label those. I'm going to move. I have this tendency to not think ahead for some reason. I'm always like, I got to move that label. So that green label right there is, this is FS. Oh, what did I do? Shoot. Okay, it's back. Got to get rid of this. There we go. Okay. I always do, this is a FS max is what I've got there. So this, I'm just going to call this F sub S X, and this is F sub S Y. So you said NX minus.
I said
so it's, sorry, plus, right?
Yeah.
Okay. Plus F sub X Any other forces in the x direction?
No.
You are correct. So that is it, equals. And what is the acceleration in this situation when it's about to slip?
Isn't it the forces are pointing towards the center of the circle. I would say centripetal acceleration, right?
Yeah, it is. It is going to be the centripetal net acceleration. A lot of people want to say it's going to be zero because it's not slipping. Oh, but it is accelerating. We just can't forget that it's going in a circle with the center over here. So that's a common mistake. Everyone wants to say, oh, it's a Hill problem. Not quite. You see how there is that centripetal acceleration we have to consider. So what that gives me is n sub x plus, plus f sub x is equal to mv squared over r, right? Then I'm going to get more specific. How can you write n sub x?
As n sine theta.
N, let's make sure, yep, n sine theta. Plus, how can you write f sub x? Just the next simplification.
Static friction max cosine theta. Cosine.
Yep, cosine will give you the x, cosine theta. And then that all adds up to mv squared over r, correct?
Yeah.
Okay, great. I want to do one more substitution because I can even be, we call it, the more explicit you get, the more specific you are. This is about as explicit as I can get n sine theta for that. But how can I write this Fs max a little more explicitly?
You can do normal force multiplied by the coefficient of static friction.
There you go. Times normal force, not nx, but the normal force itself. Okay. Mu s times n times cosine of theta is what gets me. So that's that, and then it's just still cosine theta equals mv squared over r. Now we are halfway through. You can see why this is a brutal problem, that if you don't know what you're doing, it's almost too long to do. So this is why we need practice. If, for whatever reason, if this is the 1 year in 15 when they put the bank term problem on there, we just want to know what to do. Let's go ahead. And by the way, if we don't get the right answer, it doesn't matter. We got all these steps. What do we do on the y side? Let's see if we can tackle that side.
So for the net force, I said it's, well, you have three forces in the vertical direction.
What are they?
N sub y.
Okay.
Static friction.
N sub y, positive or negative for that?
Positive.
Great. What else?
And then static friction sub y. That should be negative. And then
positive or negative on that one?
Negative.
Negative. What else?
And then mg.
Positive or negative?
Negative.
Minus mg. Now for this direction, what is the acceleration in this y direction?
0.
It is 0 for this instant. It has not slipped yet. It's not going up the ramp or down the ramp. It is 0 for that instant. Okay. In that vertical direction is 0. That gives us, and I'm just going to rush through and go ahead and do the same thing you did before. Ny is going to be n cosine theta. And then we got minus Fsy is Fs max times, I'm getting sine of theta.
Yeah.
Equals, I'm just going to put it like that, equals mg. I'm not sure if that's what I want, but now here's the thing. And this is the, on this problem, if you actually got this on the AP exam, actually, we got to do one more. I messed up. We got to do one more thing. This one is done. But how can I get to this? Just one more step, as we did before, more specific.
You could rewrite Fs max as normal force.
Yeah, there we go. That's all we had to do. Equals mg. Now, so these are our two equations that you have to solve simultaneously. The good news is, if you cannot solve these simultaneously, who cares? You have gotten most of the answer here. It turns out, and you learn this when you take the practice test I'm going to give you, the last point, you could spend 20 minutes on the last point alone. Don't bother. If you've got it all set up and you need to move on, do it, because you've got almost all the credit here. and it can be diminishing returns if you're like, no, I need the right answer. Don't get stuck on that. It's all about the steps. In fact, this problem just so far, we may have already gotten our 5 for this problem. And the fun part is solving these simultaneously. I say fun with a serious tongue planted firmly in cheek, because this is a big, ugly mess that we're going to try to solve. And so what I'm going to do here is see if there's some way that I can solve for any of these variables. Now, we got to keep in mind this is symbolic. There are certain constants. M and theta are constants. V is a constant. R is a constant. Those are already known. Those are given in the problem. It's just the normal force. We don't know what that is. And we don't know what V is, right? I think I misspoke.
Right.
V is not known. We do know what theta is. We don't know what V is. So that's one of our unknowns. Now, so we got a couple of choices how we want to solve this simultaneously. Dr. Lev, you got something to add here?
Yeah. You look at the equation on the right, you factor out n, and you basically solve for n.
Great idea. Now, see, I wouldn't have come up with that. I would have like struggled around, maybe solving for one of the things. But what Dr. Lev is saying is, hey, if we just do this, n is a common factor there. Cosine theta minus mu s sine theta equals mg. Hey, guess what we just did? We just solved for n, mg over cosine theta minus mu s sine theta. Now
you can go to the equation on the left and also factor out n only on the left-hand side.
Fantastic.
Instead of n, what you just found.
Plus mu s cosine theta equals mv squared over r. And I could just take this now and plug it in for that. So here's what I'm going to get for this whole thing. I am getting, plugging that in, I'm getting mg over cosine theta minus mu s sine theta. And just a note that it took all 3 of us. I would have struggled for that for at least a little bit of what to do. But, you know, you get a PhD on your side, it sure doesn't hurt. And then that goes there. Then I got on top of here is sine theta plus mu s cosine theta, all in parens. And that equals mv squared over r. Check it out. This is our final equation, but what doesn't matter?
The mass.
No, it doesn't even matter with friction. A Mack truck or a VW will have the same maximum velocity. All I got to do to find V is multiply both sides by what?
Radius.
Yep, multiply both sides by R. Boom, there it is. I just take the square root this side, square root this side. Done.
So what is hard here? It's easy to find V if you know theta. But how do you find theta if you know V? That's harder.
That would probably be a lot harder. That's why I did it only on the no friction case. I do not know. I mean, we'd have to do that whole problem to figure that out.